Hi class, welcome to 5.2a lesson, volume of cylinders. I feel like today's lesson is going to be pretty straightforward for us all, as long as we know how to calculate the volume of the area of a circle. There's just one extra step when we calculate the volume of a cylinder. Okay, so let's start with this example. Gunnar started his summer job doing swimming pool maintenance. He has to do the following for each pool: drain each pool, build a cover for each pool, and determine how much material is needed to cover each pool. Uh, and then after covering each pool, Gunner needs to fill the pools back up with water. This is the volume. He has to calculate how much water is needed to fill each pool to a depth of 1 meter, 2 meters, 3 meters, and then 4 meters. Okay, so right now in pool number one, this is a rectangular pool. And in order to know how much volume this rectangular pool can fit, the first thing we obviously need to do is calculate the area. So we know that a rectangle, the area is going to be length times width, which is, in this case, it's in meters. So we realize that the area of this rectangle is going to be 6 meters squared, right? And then really, if we know that the area of the rectangle is 6, the only other calculation we need to know is the depth of the pool, right? Once we know the depth, that gives us the third dimension, and that gives us enough information to calculate volume. So if the pool was 1 meter deep, it would be 1 times 6, basically the area of the rectangle times the depth, and it would be 6 meters cubed. If it's 2 meters deep, it would be 2 times 6, which would be 12 meters cubed. 3 meters would be 18, 4 meters would be obviously 24 meters cubed. Okay, so you're starting to see that finding the volume of a rectangular prism in this case, or a cylinder, should be the same, right? It's the same process. Even a triangular prism like this, right? What you do is you find the area of this triangle first, which is a 4 by 4. We know that the area is base times height divided by 2. So we know that this is going to be 4 times 4 divided by 2, which is 8 meters squared. And then if the depth of the triangular pool is 1 meter deep, it would be 1 times 8, which is 8 meters cubed. Notice how you have to label correctly. 8 meters cubed is totally different than 8 meters squared, right? And 2 meters deep would be 2 times 8. 3 meters deep would be 3 times 8, which is 24 meters cubed. Okay. So describe in words how to find the volume of the pool for any given depth, right? So really it's to find the volume. Multiply the area of the pool by the depth of the water. That third dimension is the depth, right? The area on the top is kind of like that top layer, that area, and then you multiply it by the third dimension, the depth, and you will now get volume. Okay, so sometimes we write this as the volume is equal to, for any prism or cylinder in this case, the volume of any prism is always going to be big B, capital B times H. The reason why we capitalize B is because we don't want you to think that it's just the base of something. This is a capital B, which means the area of the base. And then obviously the H is, or you can call it the D if you want, but it's the depth of the object, the depth of whatever you're talking about, the pool or the cylinder, the can. And so technically, this capital B can vary from depending on what shape, right? In this case of the pool, we were talking about triangles, but in this case, we're talking about rectangles. And then in the very next page, you'll see that we'll be soon talking about cylinders, which we know that the area of the base in that case would be pi r squared. Okay, so let's go ahead and try calculating the area of this triangular prism, right? Uh, this triangular prism has, so this area would be the big B, and this right here would be the H, the depth of this prism, right? So first calculate the area of this triangle. So we know that V equals big B times H. And in this case, big B is going to equal 6 by 6 divided by 2, which is 18, 18 millimeters squared. And then the H is going to be 8. So then the volume is 18 times 8, which I'm going to try to do that in my head. 18 times 8 is 18 times 10 minus 36. Is that 144? 144 millimeters. And make sure that you do cube your final answer. Okay. So that's how you calculate the volume of any prism. Right? I feel like we talked about this in Math A. We definitely had to calculate the surface area of triangular prisms, but really, you always focus on this area, right? This is what dictates what kind of prism it is. The fact that this is a triangle tells us that this is a triangular prism, right? In number 5, you can see that this is a trapezoidal prism, right? It's like this shape, there's an infinite amount of these small planes that kind of form this type of prism, right? So the key to finding the volume really is finding the area of this first shape and then just multiplying it by the depth. And that's how you calculate the prism volume. Okay. So some of us may have forgotten what the area of a trapezoid is. So let me remind you, right? Area of a trapezoid, right? Please write this down. It's really good. Base 1 plus base 2. It's really just you're adding the two horizontal elements of the trapezoid together, the two parallel sides. You divide it by 2 to find the average of it. Then you multiply by the height of the trapezoid, which is going to be, like in this case, the 4. Okay, so my area of trapezoid, big B, I call it big B or capital B, is going to be 5 plus 8 divided by 2 times 4, right? So 5 plus 8 is 13. 13 divided by 2 is 6.5. 6.5 times 4 is 26 feet squared. The height in this case will be just a 12, the depth of 12. And you can see that if this two-dimensional value multiplied by the third dimension will in fact give me a three-dimensional answer, right? So the volume is going to be 26 times 12, which is 312 feet cubed. Okay, so far we've calculated the volume of a triangular prism, a trapezoidal prism, and then soon I feel like we're going to calculate the volume of a cylinder or a pool or jacuzzi, whatever type of shape it is. So number 6 says Gunner has one more pool to work on. Ooh, okay. Use what you know about the formula V equals big B, capital BH to find the missing information for pool number 3. Each unit represents 1 meter. Okay, so it's first asking you, do you remember how to calculate the perimeter of this pool? Right? The perimeter of a circle, the way to say the perimeter of a circle is really the circumference. Let's go ahead and write these formulas down one more time. The circumference is always 2 times pi times the radius. And according to this picture, our radius is just 1 meter, right? The area of a circle is always going to be pi r squared, right? So in this case, it would be pi times 1 squared, which is pi, or pi meters squared, or obviously 3.14 meters squared. The circumference in this case is 2 pi times 1, which is really just 2 pi meters, or 6.28, something like that, right? So this is the actual, this is the approximate. Now, if you were to make the pool deeper, then you would have to take the area and just multiply by the depth in which you want to extend your pool, right? That's obviously making the pool deeper will increase the volume. So all I need to do is take the area of this pool and just multiply it by the depth, right? Remember, V equals B times H. So this is the big B, and all we have to do is multiply by the height. So 3.14 times 2 is going to give us 6.28 meters cubed. 3.14 times 4 is going to double this, right? You double the depth, of course you will double the volume, right? And that should make sense. That hopefully that makes sense. 6.28 times 2, I think that's roughly 12.56 meters cubed. And then 3.14 times a depth of 10 is going to be 31.4 meters cubed. Okay. What type of three-dimensional object is pool number 3? Well, obviously it's a circle on the top, and then it has, the depth, which is like that. And this is what we call a cylinder. Okay. Anytime you want to find the volume of a cylinder, we know it's V equals big B times H. Again, I'll repeat, write these notes down. It's going to be the area of the base. And this is going to be the height of the object. This is true for any prism. And this is also true for a cylinder. Technically, a cylinder is not a prism because a prism needs to have edges, but this still kind of looks like a prism where it's like an infinite amount of circles according to that depth, right? And all you have to do is find the area of this circle. So really it's pi r squared h, because pi r squared is going to be the area, and then h is going to be the depth. Sorry if I wrote that a little bit scrunched, but it's pi r squared, which is the area of a circle. Area of the circle. And then this is going to be the depth of cylinder. Okay, let's try one example, and then obviously we can have you try the rest. Okay, so if we have something like number 9, where they give us the radius and they give us the height of the cylinder, right? Let's write that down. R is equal to 3 inches. H is equal to 5 inches. Well, then we know how to find the volume, right? Volume equaling pi r squared h, because pi r squared is the area of the circle, and then times h, the height of the cylinder. That will give us the volume. So you can use you are advised to use your calculator, and whenever you use your calculator, please use 3.14. In this case, it's going to be 3 squared. Obviously, the order of operations tells us to square the 3. 3 squared is 9. 9 times 3.14. Let's see what that is. 28.26. 28.26 times 5. I'm getting 141.3. This is going to be inches cubed. And then box your answer. Following a simple formula. Okay, let's stop the video right here. I think obviously you have a lot more practice ahead of you. So let's just go ahead and practice on your own. Thanks for watching.